for this opportunity given to me to present my work. As you rightly put it, this is one of the chapters of my thesis with a broad theme of agricultural productivity and food security of rice production households in Ghana. For today specifically, I'm going to talk about choice of rice production practices in Ghana. We're looking at the empirical estimate of some of the two competing models in the choice modeling literature. That is the mixed logit model and then the WTP space model. I'm pretty much sure by the time I'm through the presentation, you would understand what is WTP space model or willingness to pay in space model. For this morning, I'll take you through the introduction, the choice modeling procedure, an econometric model. I promise not to bore you so much with the equations, and the empirical results, findings, and conclusions. Now, basically, rice is a food security crop when it comes to Ghana. And it's one of the cash crops that has so much effect on the diet of the population. Currently, it's about 34% of the total expenditure to cereals. It's spent on rice. Now, it is estimated that the per capita consumption of rice is about 68 kilograms per capita per year. Now, the problem here is that the demand for rice keeps increasing, but the supply is not matching up. And so what we do as a country is to import rice from various countries around the globe. But the key problem here is that we cannot continue to rely on the international market because it's fairly unstable. And given the fact that rice is a food security crop, then we need to find ways and means of increasing productivity within the country. So there are calls for the introduction of new technologies to boost rice production in Ghana. But the critical question is, what really would farmers prefer, or what would they want in some of these new technologies? Because there are instances where technologies are introduced, but take-up is low, and of course, we don't end up achieving the desired goal of improving our productivity. So we thought, oh, it would be great to have a look at what farmers' preferences are when it comes to rice production technologies, so that will inform policymakers in their choice and design of new technologies. So for our first question, we look at the preferences for modern rice production practices in Ghana. And this theme is going to run through the presentation. When it comes to studying preferences, there are two key approaches in the literature. We have what we call the revealed preference approach, and we have the stated preference approach. Revealed preference simply means you're looking at the actual choices that have been made by the farmers. In terms of the stated preference, you're looking at hypothetical scenarios. So assuming this were the case, what would the farmers have selected? Now, we have decided, because we want to imply policy before the policies are introduced, we have decided to take a look at the choice modeling procedure. Choice modeling procedure is simply based on what is called a random utility theory, which says that consumers, in this case farmers, are utility maximizers. And in the literature, one of the common approaches that is applied is the conditional logit model, which is just the relationship between choices and the attributes of a technology in this case. Now, the critical challenges with this model is that it assumes an equal preference, and we all have the same preferences for the attributes of a technology. But in reality, that may not be the case. So there are calls for us to account for the variation in taste and preferences. That is when we have the term heterogeneity. That's when it comes in. And when you have to account for heterogeneity, then there's a need for us to use a model that has that capability to address issues of heterogeneity. So then the mixed logit model was introduced by Train and his cohorts. Now, the estimation of the mixed logit model requires that we assume a distribution for our parameters. And for a distribution, it could either be normal distribution, log normal, triangular, uniform, or whatever distribution you may know of. Now, the selected distribution tends to have effects on the willingness to pay estimates that we derive from these models. By willingness to pay, we are looking at the marginal rate of substitution between the monetary attributes and the non-monetary attributes. So you have a set of monetary attributes and a set of non-monetary attributes. And you take a ratio of non-monetary attributes to the monetary attributes, then you have the willingness to pay. And assuming you have your monetary attributes having a normal distribution, and you have the non-monetary attributes having a log normal distribution, it means that the willingness to pay is going to have a ratio of normal to log normal, or a ratio of log normal to normal. And the issue is, how do we describe such a distribution in real terms? It's quite difficult. As Kappa would put it, such is an inconvenient distribution. And so there were calls for the need for us to take a look at how we could deal with the willingness to pay distribution problems within the mixed logit model. And so they said, okay, in the mixed logit model, what you do is that you first of all derive your coefficient, your utility coefficients, and then you divide by your monetary attribute to get your willingness to pay. So that's an indirect approach. What if we take a direct approach, so such that the coefficients that we get from our model estimates are directly willingness to pay estimates? So we don't have to go through the second stage of dividing. And if that is the case, then we have control over the distribution that we choose for our willingness to pay estimates. So then we can avoid issues with log normal to log normal or normal to log normal distributions. And such estimation procedure is what we call willingness to pay space. That is WTP space. And it is just nothing by just restructuring your preference space model to be such that the estimates that you get are willingness to pay estimates. Since this new model was introduced, there have been various attempts to try and compare the two models in terms of how they measure willingness to pay. And in the literature, we have a bit of conflicting evidence. Some findings indicate that the preference-based model is better, and others also think willingness to pay space models are better. And so we thought, okay, what do we do next? We want to find out which is the preferred space, preference space or willingness to pay space. So that's about the model estimation procedure. Still within the mixed logit model, I'm not trying to confuse you. It's been introduced that, when decision makers or respondents are making their choices, they are supposed to consider all attributes presented to them. So such that there's going to be a trade-off. If you decide to choose one over the other, there should be a trade-off. But what research has shown is that some respondents decide to use some simple procedures to make their selections. So instead of thinking of making trade-offs, so okay, just look through and then just make their selections. When they're going through just thinking process. And one of the such critical issues is what we call the attribute non-attendance. That means that you indicate whether you considered a particular attribute in your selection or not. And research has shown that attribute non-attendance tend to affect willingness to pay values. The point is, if one person does not consider an attribute, but the person's coefficient or utility is used in calculating willingness to pay, then there's going to be a bias in the willingness to pay estimate. So we say we need to account for such decision-making behavior. That brings us to our third question, which is, what are the effects of ANA on willingness to pay estimate in preference and WTP space. So we have three key questions. One, which is empirical, the preferences of farmers for modern rice technologies. And we have two, which is methodological. We look at comparison between preference space and WTP space models. And the third is looking at the attribute decision-making process of respondents. How did we do this? So we took a special case study in Ghana. We selected two main regions. So we have the Upper East region and we have the Northern region. And basically we considered farmers in these two regions. And we selected these two regions because they are the major rice production areas. So if there's going to be any policy, then of course they are going to influence the policies that come up. In the choice modeling framework, the first thing we had to do was to define our attributes and their levels. By attributes, you're looking at characteristics of a given technology. In our case, it was rice production practices. So what we did was we identified 7 attributes. We had yield, gross margin, labor, then we had cultivar choice, weed control technology, cropping pattern, and risk. After defining our attributes and our levels, we used an experimental design to generate choice sets. That is the mixing of the attributes, in simple terms. And so we generated 36 choice sets, and to reduce the kind of burdens that farmers will have to go through in making choices, like going through choices over 36 times, we decided to block them. So we grouped them into 3, block 1, block 2, block 3. So each farmer faces 12 choices instead of 36. In our design, we had 3 alternatives. So alternative 1, alternative 2 were new technologies we're introducing. And the third alternative was a base scenario, what their current situation, their current practices are. These are sample choice sets. So we have farming system A, farming system B, and of course farming system C, which is neither A nor B. So you just want to stay with what you have. And of course, there are various combinations of rice, yield, gross margin, labor, cultivar choice, weed control, cropping pattern, and risk. We had to redefine the attributes in a pictorial from like pictures, because it's a developing country's word. And as much as possible, you want farmers to relate with what you are talking about. It was not easy trying to get pictures. But eventually we managed to get them. So that's how the choice set looks like. And each farmer faced 12 of this. So we designed a questionnaire that is made up of the choice set as you saw and some socio-economic characteristics. And the questionnaire was administered to 306 rice farmers. And the data collection process was assisted by 6 research assistants, because I was working in 2 different regions and I needed to be able to move quick. So I decided to hire the assistance of people to help. So that's where we have come to. We have defined our problem and then how we conducted our survey. We now take a look at the analytical framework. How did we analyze our data? Typically, when you get your data, the first model you would want to estimate is the conditional logit model. But as I indicated, it is a homogeneous model. It means that all preferences are equal. So the first thing we did was to estimate our conditional logit model. And then we needed to also account for heterogeneity, variation in taste and preferences. Under heterogeneity, we had the utility space, or what I've defined as the preference space, and then we have WTP space, which I have called, of course, willingness to pay space. Now, within each of these two models, we have a model where we allowed independence among the parameters, and then we have one that we allowed a correlation, and that's what we repeated for the WTP space model as well. I'll just show you the econometric model in a bit. So I have labeled as equation 1, equation 2, and equation 3. So principally, this is the preference space model. We have utility, which is dependent on your attributes and an error term, because you cannot account for everything. And so in essence, this is the utility space model, a model that is dependent on attributes and the error term. But when it comes to WTP space, what we're trying to do is we are trying to make sure that we normalize the cost, or in our case, the monetary attributes, such that the estimate that we'll get to be willingness to pay estimates. So we have separated these attributes, that is a composite of monetary and non-monetary attributes, here into monetary and non-monetary, such that we end up normalizing when we divide the BNC by BNK, we get willingness to pay attributes. Sorry, willingness to pay estimates. Here we have normalized C so that we don't get the, it's not, we have set cost of monetary attribute to 1, and then so that the rest of the parameters will be willingness to pay estimates. As I indicated earlier, this is just the probability that a farmer will choose from a given alternative, having a conditional logit model, and then this is how you would specify your mixed logit model, and of course the WTP space model, the willingness to pay space model. I wouldn't go much detail into this, but if you have questions, you can ask afterwards. Okay, so I'll now take you through to our empirical results. So we have mixed logit model correlated and GMNO model correlated. What I have done is I have decided to just present the correlated model because in all instances they were the best. So I said, okay, let me just present the best models I had. So I realized that, of course, in here, how to interpret that positive coefficient means farmers prefer such attributes or give them greater satisfaction or utility, and negative means that there is a dissatisfaction with that particular attribute. So we realized that for gross margin, it's positive, yield is positive, which is what we expected. That farmers will prefer higher yield, they'll prefer gross margin. And of course, consistent with the literature, you also find that farmers also have a bit of dissatisfaction with high labor use or high labor requirements associated with technologies. Yes, so we tend to have a bit of consistent results in the willingness to pay estimate as well. You have gross margin, which is, I said, has been what? Normalized to 1. And then you have your yield, which is positive, which is what we expected. We have labor negative, which is what we expected as well. So really the model seems to be behaving well and is consistent with theory. In terms of model fit, we realize that if you compare the log likelihood estimate, then our willingness to pay space model is performing better than our preference space model. Okay, so we then proceed to calculate our willingness to pay estimates. In the mixed logit model is a ratio of all these attributes to the monetary attributes. In here, our monetary attribute is gross margin. So if you realize that farmers associate positive value with yield, with chemical reading, and rise follow system. So you have ones one season of rice production, and then the next season has followed. We come in here, the GMNL model 2, we have still positive value associated with yield, negative associated with labor. So in essence, we realize that the two separate models are having similar estimates, like they produce similar results. But the issue, as I raised earlier, was with the distribution. So when you look at this distribution, this is a ratio of normal to log normal. And you can clearly see that this is not a normal distribution, and it's quite difficult to give it a particular name because it's a ratio of normal to log normal. When you compare this to our WTP space model, it looks quite tight and as normal as you would want it to be. So just some brief findings on this. We said that farmers will have preference for higher gross margin, yield, and it's also a disutility for high risk and labor requirements. And for our two models, the WTP's willingness to pay estimates are equivalent, but the distributions are not. And of course, as I said, the WTP space model performs better than the preference space model. So this answers our first two questions on the preferences and the comparativeness between the two models. Now, I will take you to the attribute processing strategy. Basically, what is usually done in the literature is that as part of your choice modeling questionnaire, you ask the question of, did you attend to this attribute or not? In essence, did you consider yield or not? Did you consider labor, gross margin or not? And on the basis of the responses, you incorporate them in your model to see how that also affects your willingness to pay estimates. Now, based on the literature findings, we've realized that sometimes respondents will say, yes, we ignored a particular attribute. But in real essence, that attribute was not ignored. They only placed minimum or less importance on that attribute. So we said, okay, instead of having a single yes, no, we should rather have a model that accounts for the level of importance that is associated with each attribute. So what we did was have a set of questions to rank from 1 to 7, just as we had our attributes. And then what we did was to interact the ranked data on each of our attributes. And then we estimated the model within the preference space and the WTP space. Let's see what really happened to our findings when we do such a thing. So we realized that yield is still positive. And look at the interaction, it's positive, but we also expected that to be significant. Because if we have attached so much importance to yield, then it should be significant as well as positive. When you look carefully at this result, what we find is it's only medium cultivar and mechanical weeding that is consistent with the previous result we had without having that kind of interaction. When you also consider the WTP space model, you realize that it's only yield that also behaves consistently with the model without the attributes importance data. So it's a bit quite surprising, but what we would say it's usually so that really brings to the fore of the issue of whether respondents really provide the right responses we require. Because this is a way of trying to cross-check with the responses they had given earlier. But you find that very few of the attributes are really showing that kind of behavior. Now, we also find that, of course, in terms of model fits, we have this attribute attendance model behaving as the best of all our models. And as well, we have our GMNL model being the best of all the models that we have run. So, accounting for attribute non-attendance improves our model fit. But as to whether what the respondents report are really something that we need to consider is something that the literature may really have to give it a second thought. In the case of the ANA literature, what they say is that, okay, there is a bit of we are a bit skeptical about the stated attribute preference. Now, in terms of willingness to pay, we realize that for those who indicated that the attribute is important for labor, it's 0. It means that they are really indifferent. And I was a bit surprised that in our previous model, they had greater utility for labor. And now we try to account for whether the attribute is important, then we find labor being 0 with no sign. It's positive. So really, this is something that I really have to look at. But in essence, when you look at the willingness to pay values, you compare these ones to this, you realize that there's a very slight variation in there. So what we say is that the WTP space values are quite consistent, and ranked attribute important data also improves our overall model performance. So in essence, that's what we have done. But we also asked a typical question of what next? Because the issue is that we have come up with findings that farmers want gross margin, farmers want yield, farmers do not prefer higher labor requirements. But the issue is, do all farmers prefer yield? Do all farmers prefer the issue is, do all farmers prefer yield? Do all farmers prefer labor or gross margin? There could be a way of some categorization among these farmers, with some farmers wanting maybe yield and not gross margin, or they would want yield, both yield and gross margin. And so this is one of the issues that we intend to address next. So let me quickly conclude. Of course, I have said most of these things already. We are saying that farmers associate positive value with gross margin. And as per our study, of course, we find WTP space and preference space models as better. And studies on choice experiments should also incorporate attribute processing strategy, such as a non-attendance.